Hello and welcome to my presentation on TonePackets. Now, many of you that have been watching and monitoring the channel all know that I've released a new copy of Helium, and Helium came with a nice new chord track feature which allowed us to create a chord sequence and send that to any participating app. Now, this works using traditional MIDI note on and note off. Or alternatively, we can send something called TonePackets. And TonePackets were designed to get over several issues we have communicating between apps, especially if they're using apps or sequencers. Now, why do we even need TonePackets? And I think the easiest way to explain this is to give you an example. So as you can see here, I've got a copy of Evolver. And Evolver is quite a complicated app because it has 4 different lanes and each lane can contain its own sequence. And all 4 sequences need to be synced to tempo. So watch me play a sequence of chords on this mini keyboard and notice when the chords start in relationship to when the keys are pressed. So hopefully you noticed there that all 4 lanes started immediately and together in sync, and they started after I pressed the chord. So it's important that the chord is actually registered before the next beat. If we fail to register all the notes of the chord before the next beat, the chances are that the app will sound different each time we play that chord. So it's very, very important that the notes arrive in time for the next beat. Now, traditionally we would record our chord sequences into a MIDI sequencer, and that would lead to problems, but the chord track ensures that every note of every chord arrives in time or ahead of time, and we can control that by sending either MIDI notes, note on and off, or TonePackets. And TonePackets have more advantages than just sending plain MIDI notes. Let me explain. Now, TonePackets was something devised by David Collett and Greg Riker, 2 people that have worked with me on various apps throughout the years. Now, they come up with this great idea of inter-app communication using sysx packets. Now, they say the primary benefit of TonePackets protocol is to provide an efficient and unambiguous method of sharing chords and scales between apps in real time. The protocol simplifies internal code requirements for receiving apps by offering compact and efficient alternative chord recognition and scale selection. TonePackets will enable musicians and developers to communicate any combination of up to 24 notes from a limited palette of chords, scales and note clusters. With a range of music apps supporting TonePackets protocol as senders and receivers, we hope to create new accompaniment possibilities for intelligent music creation. So that sums up what this is all about. Now, I'm one of the first developers that's jumped on board with this, and I've integrated this into a number of my apps. It's really well documented, and any developers that want to either building the ability to receive TonePackets or send TonePackets should get in touch with Greg and David and ask them for the documentation. As you can see here, they've gone into some depth in here, and it covers all the chord types and scales that TonePackets supports. As a receiver, you really don't need to implement that much. You just have to decode the incoming sysx packets and deal with them as you wish. We have demo source code that's available on request. So let's go back and take a look at Helium's TonePacket support and go in depth into how to use that to communicate with various other apps that 4Pockets has integrated TonePackets into. So we have 4 apps available for you which work as receivers right now. So Helium is an example of a TonePacket sender. It can send TonePackets, it can send MIDI data. It's up to you. Now if we open Helium and press the controller button here at the bottom, it will open up the controller lane, and this usually is where we can edit controllers such as modulation and cutoff and all that kind of thing. Now you'll notice this controller selection here has a little chevron in the upper corner, so if we long press that we can access the chord track. Now one thing I should state, I didn't state in the previous video, is the chord track cannot be used in conjunction with song mode as it stands right now, but I might change that in a future version. So to add a chord to the chord track, the first thing we need to do is enable the Add Chord tool. And with this tool selected, we can tap, hold and drag a chord in the chord lane. And again, we can resize. And if we long press on that chord, you'll see this little pop-up. Now this allows us to visualize the root chord, and we can change the root chord by hitting the root button and selecting a different root note. Now in this case I picked E, and that's an E major chord. We can soon change that to something like a minor 7th by clicking the chord type and changing the chord from that menu. Now you can also pick inversions from here, but they're not reflected in a little piano roll at the bottom here. You can also change the slash note. This is a note that's played usually 1 octave below the lowest note in the chord, in the inverted chord. Usually when we use slash notes we toggle the rooted status of this chord to unrooted. Now if we make changes to a chord and we want to hear what that sounds like, the next version of Helium has this little preview button in the top right corner of the dialog, and when we press that we can hear the chord. So that's essentially what an E minor 7 sounds like being sent to a number of apps that I have running in the background. So let's take a look at the receivers and see how to set them up. So assuming you've freshly loaded an instance of Helium and added some chords to the chord lane, nothing will get sent by default. So to enable the chord track, head off to the main menu and select chord mode options. And at the top of this menu you'll see an on-off toggle. Make sure it's on. And then click the chord anticipation option and you'll see a submenu, and the second item here is MIDI TonePackets sys. What we need to do here is turn it on. Usually it's off, as in like this. But what we want to do is click on that and click on default. That will send TonePackets, but it will send them on the beat, exactly on the beat, which is what I suggest you try first. You can ultimately come in here and change that to something like 1/16 of a note in advance of the beat if needed. In general with my apps you can just leave it on default. So with that setup complete, we can now look at sending those TonePackets to a receiver app. So let's start by looking at MIDI Strummer and how to set that up in order to receive these TonePackets. Now I'm in AUM and I have a copy of MIDI Strummer loaded here. Now I'm going to open the interface a little bit more so we can see this input menu. It's important that this input is set to the correct mode in order to receive and decipher TonePackets. Now in this case we're selecting piano to guitar, and that option allows us to do a conversion between piano chords and guitar chords. It's great as long as you stick with the chords that are already available to you in MIDI Strummer. Now I think this is one of the only app out of the 3 I'm going to show you that has this kind of conversion process. In general, a receiver uses the incoming notes from the TonePacket, but in this case there is a translation. Now if we click on the little hamburger menu to the left of Strummer, we can click on inputs and we can choose where we want to take our input from. In this case we're picking Helium and we're picking the control out port. Any app that's listening for TonePackets needs to be connected to the control out port. The other four ports are just for no on and no off and your typical MIDI data. So now if we return back to Helium and press the transport in AUM, we should hear the chords being output to Strummer. And when we press stop, a TonePackets all notes off will be sent, stopping Strummer playing. So now we've seen how to send TonePackets to Strummer, let's turn our heads to Evolver. And this is exactly the same kind of thing. Here I've got a copy of Evolver. I'm going to just make sure I turn the volume up and turn the volume down as Strummer so we can hear it. There's nothing to edit inside of Evolver, so we can just leave the interface alone. The defaults are good enough. But what is essential is that we set up Evolver so that it's taking its inputs from Helium and taking it from the control port as we did with Strummer. So now let's return to Helium and press play on the AUM transport. So nothing could be easier, we just need to connect to the right output port from Helium. So let's now have a look at the third app, I think, that is incorporating TonePackets, and that is Copperhead. So again, I've already got a copy of Copperhead loaded in an instrument channel. I'm going to make sure that, that all the other volumes are down other than the Copperhead volume. And if we head off to the main menu and look in settings, right at the bottom here we have a TonePackets mode, which is currently set to chord, but if we tap on it, it toggles between three different options. Now I'm going to leave it on chord here for now, and let's just connect up the input to Helium's control out port, and let's just see what that sounds like. So we can hear there that Copperhead is now responding to the TonePackets and playing a chord, because that's what we had set on the menu. Now if we change that to a bass and ensure we have a reasonable bass sound selected, so let me just randomly pick deep bass, that'll do. Let's see what that sounds like. So return back to Helium, rewind and play. So what we actually heard there was Copperhead play the bass note of the chord, which was kind of hanging in mid-air a little bit. So if we go back to Copperhead and change that from bass to sub-bass, it'll play the same note but one octave down. Now that isn't a great noise I picked, but let's try and listen to that in context with something else like Strummer. I think Evolve is a little bit too complicated. Let's just try Strummer on its own. So I think you get the idea. That mode is really useful in certain circumstances. Now let's turn our attention to Ukidian, which is probably the most complicated setup of the lot, and that's simply because Ukidian generates nothing more than MIDI notes. So what I've got here is one copy of Ukidian and I've just randomized some notes for each of the 4 lanes of Ukidian, and I'm outputting each of those lanes as a separate port, and they're going to 4 instances of Synthmaster 2 that are listening to notes that are coming through that port. So Ukidian is currently just producing a bunch of random notes and sending those out to the 4 individual Synthmasters. But if we enable the chord detection, you'll notice that every chord I play on this keyboard moves these notes to snap to the incoming chord. And what we want to do is not play the chord on this little keyboard, AUM keyboard, but have the notes coming in from Helium, from Helium's chord track specifically. So to do that, all we need to do is go back to the configuration of Ukidian, press on the hamburger menu, and ensure we're taking our input not from the keyboard below, but from Helium's control output. So now everything's set up correctly. If we were to rewind the transport and press play, we should hear the chords being applied to Ukidian. And you can clearly see the incoming chords here affecting the note grid of each of the 4 lanes. So now everything's set up to run off that chord track. Let's try mixing them all together. Great for any app that understands and can receive tone packets. But what happens with apps that they don't know about the protocol? Well, they're not left out. They're not left behind. The chord track can also output MIDI notes to something like Synthmaster. So I've got a copy of Synthmaster here, and I've got an organ sound set up. And for Synthmaster to receive notes from the chord track, we just connected it a slightly different way. Instead of connecting to control out, which is for tone packets, we're going to select port 1. Now in Helium, by default, every track sends to its own channel. So track 1 will send to channel 1 on port 1. Track 2 will send to channel 2 on port 1. But I suggest what you do is to configure so that, say, track 2 is output into channel 2 on port 2 or bus 2, and so on. So if you configure channel 3, set that to channel 3, port 3, and so on. Now the first thing I'm going to do is switch back to track 1, because track 1 is output into port 1. And I'm going to go back into the main menu and back into the chord mode options. Pick chord anticipation, and you'll notice that the MIDI out for track 1 is currently on. Make sure it's not turned off. Now what that means is that MIDI out is going to be routed to port 1. So let's just switch everything off except for Synthmaster. And the great thing about doing that and being able to use tone packets and MIDI note data is that you can set the anticipation value for the different tracks. Now in all these cases we've set the anticipation value to default, and default just means on, but with sending directly on the beat, not before the beat. If we want, we can specify a value like quarter beat, 8th beat, 16th beat, and we can set that different values for different channels. So I've selected track 2, and I can go in here now and we can set the chord anticipation for track 2 to a 16th of a beat. Okay, so we have complete control over that on a track by track basis. Now this is all well and good, but not all DAWs unfortunately support SysX. Now it's been part of the MIDI standard for many years, so I'm not quite sure why, but 2 of those programs are Logic Pro and Cubasis, so they need to get their act together and support SysX. Now while that's a real bummer, we just hope that more developers jump on board. It hasn't stopped me progressing and developing TonePackets within my apps. So that's just about it for this video. I hope it's helped make you a little bit wiser as to what TonePackets are. Don't forget to subscribe to the channel and thumb up the video. I'll see you next time.